Hi, my name is Nick Pulsone, and for my Immersive Scholars work experience, I worked under Professor Ahmadzadeh in the Pro Robotics Lab to implement a learning from demonstration algorithm using Canal Surfaces. As an alternative to manual programming, robots are often taught how to carry out a variety of tasks. Learning from demonstration, or LFD, is a family of approaches that allows us to implement the system of teaching the robot. In LFD approaches, the robot is shown at least two examples of how to carry out a given task, and can then perform the task in a different setting than was originally shown. Robot learning methods are often very complicated, but many LFD approaches allow us to teach the robot in ways that are intuitive to non-experts. Many LFD approaches implement robot learning with geometric representations. For our approach, we use canal surfaces. Canal surfaces are essentially cylinders, but with a spine that can be any curve in 3D space, and with cross-sections that have varying radii. Canal surfaces give us a robust and adaptive method to teach the robot skills that can eventually be generalized to different situations, that can be easily understood by even non-experts. Depicted on the left is an example of a canal surface generated by the algorithm I implemented, using demonstrations of a robot picking up an object and placing it back down. The blue lines are the demonstrations, which we use as the 3D position of the robot's end effector or gripper. The red line is the spine curve, and the gray circles are the cross-sections. To carry out our approach of learning from the canal surfaces, we start by recording the position of the robot's end effector in 4 distinct ways. Then, we generate a canal surface that encapsulates all 4 of these demonstrations. At this point, the robot has learned the skill, and will now generate a new curve based on a new given starting position. Lastly, we execute the generated motion on the robot to complete the reproduction process. Here's an example of teaching a robot a basic reaching skill. Shown are 2 of 5 total examples of showing the robot how we want the task completed. In this case, we use kinesthetic teaching, where we record the position of the robot's gripper as it is physically moved. We use the recorded data to create a canal surface and then reproduce the motion based on an arbitrarily chosen starting position. The same color scheming is used, with the green line representing the reproduced motion, and then we execute this motion on the actual robot. All my code is free and open source and can be found on the GitHub link on the screen. I would like to thank Professor Ahmadzadeh, the Pro Robotics Lab, URock, and UML for this great opportunity. Thank you for watching.